In today's video, we're going to be reviewing over equations. Now, an equation is a mathematical sentence that has an equal sign, and it is also a mathematical sentence that's always going to be true. It's going to always be balanced on both sides. Now, the equations we see this year usually have a variable, which is a letter that represents a number. So the basics of an equation, first of all, your equal sign shows where your sides of the equation are, where it has to be balanced. So right here determines the left and the right side of your equation. All right, both sides have to be balanced. All right, now in a two-step equation, whenever you have to move a number or to balance it or manipulate the numbers, you have to do the opposite operation in order to go to the other side of the equation. So, for example, if I have 2x plus 1, I have to do the inverse operation and have minus 1 in order to balance my equation out. So you have 2x equals 6. The inverse operation of 2 times x is dividing by 2. So I'm going to divide both sides by 2. And you get as a final answer, should be canceling terms out to show that they balance. And then I get a final answer as x equals 3. And you could check this by plugging it in back into your original expression. And 2 times 3 plus 1 is 6 plus 1, which is 7. Okay, and that's a way to double check your answers. Now, sometimes equations will have parentheses in them. For example, this one right here. Whenever there's parentheses, we are using the distributive property. That means you're multiplying the 3 by both terms. You're multiplying by the x, the 1x, and you're multiplying by the negative 6. So 3 times x would be 3x. 3 times negative 6 is negative 18. And again, I like to draw the line down my equation just so that it distinguishes the sides and when to do the inverse operations or not. So this would be a problem you have to be careful of, because the opposite operation of minus 18 is plus 18. So I'm going to add 18 to both sides and get 3x is 36. That opposite operation is dividing by 3. So again, my final answer is x is 12. And when I do these inverse operations, they cancel out on this side. Now, whenever I have an equation that looks like this, let me fix this. Okay, I'm going to put my line down the equal sign to determine my sides. Whenever you have an equation like this, you have to make sure each side is simplified as much as possible. Now, before you do that, you have to see if, look on the left side of our equation here, we notice we have 2 terms with variables. We have the 2x and the 3x. Those are called like terms. So 2x plus 3x is 5x. Then I'm going to bring the other 5 down. There's no other like terms with that one. And we get 5x plus 5 is 30. Subtract 5 from both sides. And we get 5x is 25. Divide both sides by 5. And you get x is 5. These cancel. These cancel. So you only combine like terms on one side of the equation. A lot of times, a common mistake students will do is they'll do this. They'll minus 3x and minus 3x. But you can't do that because it's on the same side of the equal sign. You only can combine like terms on the same side of the equal sign. Now, say you had variables on both sides. All right. Now, when this is the case, you would have to, I always try to focus on bringing the variables over to one side first before bringing the constants to the other side. So in this case, what I would do is I would minus 2x, the smaller variable, term with the variable, from both sides. That way these guys cancel out. And I'm left with 9 equals 4x minus 2x is 2x plus 15. Then it becomes a two-step equation. Minus 15 from both sides. And you get negative 4. Divide both sides by 2. And you get negative 4 divided by 2, which is negative 2. All these terms canceling out. So again, we have variables on both sides. Bring the variables over to one side first by doing the inverse operation. Okay, then bring the constants over. One last scenario I'll show you, which you could have a combination of multiple scenarios. You could have, here, just write it. Minus. Switch this to 3. All right. So this equation, first you look at the left side. What can I do on the left side to simplify it? Okay, you have like terms, right? 2x plus 3x, which is 5x. Thank you. On this side, you can distribute. Now we have a equation with variable on both sides like we did before. I'm going to minus the 5x from both sides. And you get 2x. add the 21. And anytime I go across that line, that equal sign, you got to do the inverse operations. And you will get 32 is 2x. Divide both sides by 2. Then you get x is 16. So again, with the more complex equations, make sure you combine like terms first or distribute before you do start doing any inverse operations. Some reminders on maybe some word problems you might see when you're dealing with consecutive integers and you're setting up consecutive integer word problems. For example, if I'm looking for 3 consecutive integers, I would set up my equation using x plus 1, and x plus 2. And then add them all together and say like 3 consecutive integers whose sum is 21. So you would add up the x plus x plus x, which is 3x, add the 1 and the 2, which is 3, equals, like I said, 21. 3x plus 3 equals 21. And that's how you would set that equation up. If I wanted an equation where you had 4 consecutive integers whose sum is 86. So you would set it up x plus 1, x plus 2, and x plus 3. These are my 4 consecutive integers whose sum, so I got to add them all together. So you get 4x, 1 plus 2 plus 3 is 6, equals 86. So that's with consecutive integers. Then once you figure out your x, you got to plug it back in to figure out each number. It should be in order. Now, if I said consecutive odd or consecutive even, say I want 3 consecutive even integers whose sum is 100. Instead of x plus 1, and x plus 2, since you're dealing with even numbers, their differences x plus 2, and x plus 4, which would be 3x plus 6 is 100. Now, I said odd, 3 consecutive odd integers. I won't say 3 for this one. Let me say 2 consecutive odd integers. Again, it would be x and x plus 2, which we'll say are sum of 2 consecutive odd integers whose sum is 20. You add them together, you get 2x plus 2 equals 20. Again, once you get your x, you plug them back in to your terms. So notice the odd numbers have the same expressions as the even numbers. Remember, because even numbers, 2, 4, 6, 8, you're just adding 2 to them. Same thing with the odds, 1, 3, 5, 7. The difference between those is you keep adding 2. So if I wanted 4 consecutive odd integers, I would set it up x plus 2, x plus 4, and x plus 6. And these would be my consecutive odd integers once I figured out what my x is. Also, one last thing when you're talking about perimeter. Perimeter is when you are finding the total distance around a figure. So if I have a rectangle, usually the case is always the case is the opposite sides of a rectangle are equal. So you would have like 2x plus 1 up here. This would also have to be 2x plus 1. x, and x. Now you could stack them up like we did with the odd integers. And we said, let's say our perimeter in this case is 37. I'm just making up these random numbers to show you how to set up the equations. You should know how to solve them once you set them up. And then you could stack them up, or you could just look at the like terms. 2x plus 2x plus x is 6x. 1 plus 1 is 2. And that perimeter is 36. Different color. 36. So that's how you would set up that equation. Once you get your x, you plug them back in. So remember, the opposite sides of a rectangle are always the same. All right, and same if you had like the perimeter of a triangle. And this one, let's say x and 2x plus 3, and this is going to be 4x minus 1. And I want to say the perimeter is 39. Combine the right terms, x plus 2x plus 4x, which is 7x. 3 minus 1 is plus 2 equals 39. And you get your x with that, whatever that equals, and plug it back in on your perimeter. So we reviewed all these different topics. We reviewed over perimeter, consecutive integers, distributing, combining like terms, two-step equations, equations with variables on both sides. All these things kind of come together, and these are like the foundation of algebra. So this is really important, you guys, to get this stuff down. All right, so that's it for today's video. If you have questions, please let me know in class.